Okay, good afternoon, everybody. Thank you for joining us. Welcome to the 2021 Better Buildings Summer Webinar Series. In this series, we are profiling the best practices of Better Buildings Challenge and Alliance partners and other organizations working to improve energy efficiency in buildings. Next slide. So I'm Haley McLeod. I'll be your moderator today. I am a technical professional at Oak Ridge National Lab, just outside of Knoxville, Tennessee, and I am the non-technical lead for the Building Envelope campaign, which is what we are all here to talk about today. I've been in the building science industry for about 7 years. Next slide. We are excited to announce that today we will be using an interactive platform called Slido for Q&A. If you've been on one of these before, you're probably familiar with Slido. But if you could please go to www.slido.com on your mobile device or by opening a new window in your browser. Today's event code is #DOE. And if you would like to ask myself or any of our presenters questions throughout the presentation, please feel free to submit them anytime throughout. We'll be answering them offline after the webinar is complete because all of our presenters are not live with us today. So please be sure to include the presenter or the presentation that your question is about so that we can get those to the right folks at the end of the presentation. After the fact, our team will email you with a link where you can find the written responses to those questions on the Better Building Solutions Center. You can also select the thumbs up icons for questions that you like, which will result in the most popular questions moving to the top of the queue and a greater chance of those getting answered. If we get a ton of questions and can't do them all, we'll obviously prioritize those that lots of people wanted to hear about. And again, just to repeat, I really request that you try to put the name of the presenter or presentation in your question to make sure that we can get them to the right place. If you have any technical issues or have any questions about this Q&A process, please reach out to the webinar organizers through the GoToWebinar chat box, not in Slido, but in GoToWebinar. Next slide. So I wanted to start this presentation off today by just giving a huge shout out to our organizers, the American Institute of Architects, the International Facility Management Association, and the International Institute of Building Enclosure Consultants, or as you probably know them, AIA, IFMA, and IBEC. They've given us lots and lots of crucial behind the scenes feedback and guidance this year, and we would not have had a successful year one without them. I would also like to take a moment here and give a special thanks to IFMA, who has donated these really awesome plaques that you'll hopefully see in the lobby of all of the buildings that we're recognizing in today's webinar. So again, big shout out and thank you to IFMA for these. Back to slides and the next slide, please. Okay, so I want to know just a little bit about who I'm talking to today. I'm always curious about who in the industry is attending these. So you should be able to see a poll up in Slido currently. So I will give you guys a few to answer. Lots of building owners and managers, that's great. Lots of government folks. Oh, this is great. There aren't a ton of others coming up to the top. Sometimes I miss a whole sector, but it doesn't look like I've done that today. So this is great. And it looks like we're still getting a few answers, but we will close this off here in a second to keep it going. Oh, yeah, there's other. I knew it would pop up. Yeah, lots of government folks and building owners and managers. I hope you're either participants from this year or going to be participants next year. So we can probably go ahead and close this poll if it's leveled out a bit and move on. Okay, so I'm assuming that if you found your way to our webinar today, you're probably at least somewhat aware of what the Building Envelope campaign is all about. So I'm only going to include a couple really high-level slides about the Building Envelope campaign, in case any of you have come across our webinar and haven't heard from us yet. So the Building Envelope campaign is a current Better Buildings technology campaign. There are a couple others that are running concurrently or are in development, and there have certainly been several in the past, but so we are in a series. So if you think you've heard of a Better Buildings Technology campaign before, you probably have, and we're kind of in that series. This one in particular was designed to help create more energy efficient buildings by improving envelope performance in the building stock in the US. And in order to do this, the campaign has introduced a new metric for building envelope performance called the BEP value. And we have also released a tool on our website to help you determine that value for your building. Next slide. So the three main goals of the campaign have been to motivate action and increase awareness about high performing building envelopes. So that's what we have been doing in conjunction with our great supporters and participants and organizers all year. That second bullet point there is recognize leaders in this field, and that is what today is all about, is recognizing those folks that have achieved really high performing building envelopes in all building types. And then that last item is demonstrate and document the energy and cost savings that comes from these high performing envelope systems. So that's kind of what our website is all about, what today's webinar is all about, and more on some website updates coming later. Next slide. So I wanted to give a high-level summary recap of year one. So 16 buildings were submitted. Of those, 14 were eligible. You're going to hear from 13 of those project teams today, and then I'm going to tell you a little bit about the 14th. Those buildings represent almost 1.5 million square feet of conditioned floor area and 9 million kBTU and about $500,000 annual savings based on envelope technologies alone. And personally, as the lead for this campaign, what I find most exciting about these numbers is that this is a really diverse collection of buildings that we are able to award in our first year. So we have new construction buildings, we have retrofit buildings, and we have multiple sectors represented here. So healthcare, education, commercial, industrial, which I think really goes to show that there are, high performance envelope solutions available to all sectors and all building types. Next slide. So that was a bit of a year one summary, and that's what today is about, talking about the successes from year one. But we are still going, and we are looking ahead into year two. So I wanted to give you a little bit more detail about that. We are looking to continue to grow. We want to recruit more participants and more supporters in the coming year and have a greater industry impact through that level of recruitment. I'd also be interested in reaching some additional sectors this year. We don't have any hospitality projects this year. Obviously, hospitality was an industry that took a huge hit from COVID that's hopefully bouncing back a bit. And you'll also notice as this webinar continues that there was definitely a bias towards new construction projects as opposed to retrofit projects. And so I'd love to reach out and hear from more retrofit projects in year two. We've also already updated our assessment tool on our website so that it includes a CO2 reduction estimator. And we are also developing a successes page on the website. So that's a mock-up of it on the right. It won't look exactly like that, but in the coming weeks, we are going to be able to post some basic information about all 14 of these buildings, some downloadable one-page fact sheets, as well as the short clips that you're going to hear today. So if you're interested in something you hear today, I encourage you to go back and rewatch the whole webinar if you want, but there will be the individual snippets available on our website as well. Next slide. The last note that I wanted to make moving into year two is that in this year, because we were a brand new campaign and because COVID did slow down the construction industry, we got a lot of projects that submitted that were either very late in construction or were post-construction when they heard about the campaign and when they analyzed their building with our tool. Hopefully this year, moving into year two, we've gotten into some heads of some folks that were a little earlier in those project phases. And ideally, folks will be able to use the campaign and the resources on our website and our assessment tool to help inform design and construction decisions. And so that's something that we're really looking forward to in year two as well. Is to get some folks that not only designed great buildings, with very little help from us, but who actually really, used our help to make design decisions. That's what we're looking for. So next up, we are going to hear, like I said, from those 13 project teams. We're going to hear from our new construction buildings first. So those are those novel 20 and 40 awards. Then we're going to hear from our retrofit buildings. So that's retro 30 and 50 awards. And then I will wrap it up again at the end. So please enjoy hearing from all of our great project teams. And thank you so much. We couldn't have done it without you.
Hello, I'm Andrew Fedorowicz, an architect and project manager with FES Engineering at Fermi National Accelerator Laboratory. I'm here to present an overview of the Industrial Center Building Edition, a recipient of the Building Envelope Campaign's Novel 20 Award. ICBA is located approximately 35 miles outside of Chicago on the Fermilab campus and is situated within the industrial building complex of Fermilab's core campus. ICBA is a 25,000 square foot state-of-the-art facility constructed to build SRF cryomodules and superconducting magnets for accelerators at Fermilab and partnering institutions. In response to Fermilab's campus master plan vision to consolidate and modernize new facilities, ICBA is an expansion of the Applied Physics and Superconducting Technology Division's footprint. The main level of the facility includes a 45-foot tall high bay assembly area with a 40-ton overhead crane used for maneuvering large components. Adjacent to the high bay program is a connecting corridor between facilities that includes the building's main entrance, equipment rooms, and a quantum computing lab. Overlooking the high bay space and above the entry corridor are two mezzanine spaces constructed for future office build-outs. Key decisions made early on in the initial planning and conceptual design phases established that the new ICBA facility would be an addition to the ICB and IB3 facilities. This approach allowed the design team to develop a strategy to unite the surrounding assembly areas and staff under one roof, while eliminating over 7,000 square foot of the building's envelope exposed to exterior climate. In addition to minimizing the building's exterior envelope, ICBA was designed to be compliant with the guiding principles for high-performance sustainable buildings. To achieve compliance, an energy model was developed during the design phase to ensure a 30% improvement over the ASHRAE 90.1 standard. Altogether, the building's cladding systems utilized an insulated precast panel for durability along the assembly areas, a double glazed insulated unit for daylighting, and insulated metal panels to reduce thermal bridging and improve airtightness of the primary facade. Vertical connections between the insulated metal panels were backed with a vertical insulated spline. This spline was sealed at each reveal to maintain continuous insulation. For the horizontal connections, the panels utilized a double gasket shiplap joint to maximize thermal efficiency and create a double barrier against air and water penetration. On behalf of the ICBA project team, thank you again for letting us participate in year one of the Building Envelope campaign and for recognizing the Industrial Center Building Edition with the Novel 20 Award.
In December 2016, VMDO was selected to begin work on the replacement of the 1950s-era Lubber Run Community Center in Arlington, Virginia. In addition to a new community center building, the project includes new outdoor recreation spaces and amenities, as well as underground parking on a 4.5-acre site. The center is located in Lubber Run Park, a precious natural resource in urban Arlington County. Connection to nature and preservation of open space were essential to designing the new building, and as a result, parking and some programs are located underground to allow for increased outdoor amenities at ground level. The 50,000 square foot facility features multi-purpose rooms for recreation programs for all ages, a fitness center with locker rooms, a gymnasium, a preschool program, community meeting rooms, a kitchen, reception, and office space for county-wide parks and recreation staff. Outdoor recreation spaces include a playground, volleyball and basketball courts, covered gathering spaces, and improvements to site circulation and streetscapes needed to facilitate access to the facility by all modes of transportation. The project seeks to blur the distinction between indoors and outdoors and promote the health and wellness of building occupants. Care was taken to maximize views to the outdoors from within, to provide dynamic daylighting to all of the occupied spaces and encourage occupants to feel connected to the park landscape around them. The building envelope that acts as the threshold between indoors and outdoors is significant in both its high performance and economic efficiency. Because burying the parking was an expensive undertaking compared to a less desirable and less sustainable surface lot, measures were taken to reduce the cost of the rest of the project. This included right-sizing building program for the projected need, providing flexibility, simplifying building geometries, and using structural materials as finished materials, including using thermomass walls in place of stone cladding. Given the extent of concrete on the site, steps were taken to mitigate its environmental impact. The thermomass system, which embeds insulation within a mass wall to improve performance, reduces the amount of Portland cement required and allows the use of the structure as the final interior and exterior finishes. Concrete used on the project employs CO2 injection, which sequesters CO2, reduces the embodied energy of the concrete, and improves strength. Once the plinth was established, a mass timber structure was employed, which further reduces the project's embodied energy. The project's material palette was deliberately chosen for low maintenance qualities, as natural finishes of concrete, wood, and copper patina over time and improve with age. The approach also resulted in some surprises, such as the cost savings associated with site milling trees, which turned out to be less expensive than purchasing conventional hardwoods. There was also the added benefit of reusing the site's trees that were significant to local community residents. Site-harvested cedar, walnut, and oak were milled on-site and converted into furniture and paneling. Areas where you see vertical seam copper siding have a fluid-applied air barrier system adhered directly to the exterior face of the sheathing. Horizontal girts were installed to support the panels, and before insulation was incorporated or copper attached, an air infiltration test was performed to confirm the performance of the system. Some small gaps in the barrier were detected, especially at the anchor points for the girts, which allowed us to return to the overall conditions and ensure the envelope was as tight as we could get it. Lubber Run recently won an AIA DC Award for architecture, where the jury commended the project's dynamism in section, thoughtful use of materials, welcoming atmosphere, and net zero initiatives. As a Lead for Communities Platinum winner, Arlington County is a sustainability trailblazer, combining forward-thinking environmental goals into its energy use standards while also balancing issues around livability, diversity, and increasing development. Many of the approaches pioneered at Lubber Run, including the thermomass system, have informed new projects currently on the boards. The lesson learned is clear. Attentive design of the building envelope contributes to healthier buildings that last longer and perform better.
Hello, my name is Andrew Cherry, and I'm a project architect at Flat Architects. I'm here today to present NC State University's new Plant Sciences building, a Novel 20 awardee in the inaugural year of the Building Envelope campaign, and the latest addition to the university's Centennial campus. The building is a 184,000 square foot academic research building comprised of wet and dry labs, faculty offices, industry partner suites, and a 10,000 square foot research greenhouse on the top level of the building. The building's program would typically indicate that it's a heavy energy user, and this building is no exception, particularly with the environmental requirements of the greenhouse. To help offset these large loads, the project team worked to reduce environmental loads on the HVAC system as much as possible, and one of the primary targets was the building envelope. The Plant Sciences building is clad in a mix of aluminum curtain wall and opaque rain screen systems. specifically terracotta and aluminum composite panels. Both rain screen systems are back ventilated and supported by thermally broken rain screen support systems. These support systems allow the project to maximize the thermal benefits of the insulation provided at opaque wall assemblies. The drained nature of the rain screen discharges moisture that manages to defeat the rain screen and enter the wall cavity, while the vapor-permeable, fluid-applied air barrier allows additional drying of the wall cavity in North Carolina's mixed humid climate. The exterior glass for the building strikes a balance between providing visual clarity and limiting solar heat gain. At public-facing areas of the building, the insulated glazing units were coated with a low-E coating that meets North Carolina Energy Code prescriptive values for solar heat gain and U value, but also allows a high degree of transparency. This clarity allows a visual connection between building occupants and the campus community, a key feature of NC State's campus character. In other areas of the building, like open offices and laboratories, a different coating was selected that exceeds prescriptive requirements, but still provides building occupants views to the surrounding campus. Glazed areas of the building utilize a traditional stick-built aluminum curtain wall system that incorporates a thermal break in the glazing pocket. When aligned with the insulation layer at adjacent opaque walls, the combination of the thermal break and insulated glazing helps to reduce heat transfer between the interior and exterior of the building. Although other more thermally resistive materials were considered for the curtain wall system, traditional aluminum curtain wall was selected in part for its ability to be reinforced, allowing the outboard attachment of one of the building's defining features, its exterior solar shading devices. While coatings can help reduce the amount of glare and solar gain attributed to glazed curtain walls, the most effective means of reducing these gains is to not let sunlight get to the glass in the first place. To reduce the amount of solar radiation reaching the glass, an array of aluminum airfoils was mounted to the outside of the curtain wall. This array was broken into a series of zones at each floor, a vision zone, a daylighting zone, and a spandrel zone. Using a genetic algorithm, the angle of the shades in each zone was optimized for its function. In the vision zone, the airfoils were tilted downward to reject incident radiation, but provide occupants on upper floors views of the surrounding campus. In the daylight zone, the airfoils were installed level to reflect daylight deep into the building and help illuminate the spaces within. In the spandrel zone, the shades were redundant to insulated spandrel glazing and interior insulation, so shorter, lighter, rectangular profiles were provided. This combination of glazing and insulation strategies allowed the plant sciences building to right-size its mechanical systems, devoting the building's energy to the occupants' research, rather than making up for excessive energy transfer across the building envelope. Just as importantly, the project demonstrates what can be achieved using materials and systems that are readily available across the U.S. when they're applied in a judicious and systemic manner. On behalf of the project team, I'd like to thank the Building Envelope campaign for this recognition, and thank you for your time and attention. Happy building!
While our equipment is making a critical impact on the environment, our manufacturing processes are too, in a good way. We strive to be good stewards of the resources we have and how we use them, from time to money and everything in between. For the last 7 years, we've been partnering with the Department of Energy to reduce our energy usage by 25% in 10 years. To help reach this goal, we have made sustainable building practices a priority in our facilities at Vermeer, including Plant 7, our newest facility in Pella. Following a tornado in July of 2018, we quickly made the decision to expand upon the 400,000 square feet of manufacturing space lost that day. The rebuilding process was quickly underway, with diligent planning that pulled on our facilities, finance, operations, continuous improvement, and strategy teams. This build had the following goals: demonstrate our 4P philosophy and help carry that culture long into the future. Implement safety measures at every team member touchpoint. Create a collaborative and respectful environment through consistent communications. Inform and engage all team members. Enable ultimate productivity that allows team members to be proud of their place of work. and outfit an agile workplace with high-quality resources to drive quality production. The basis for our energy efficiencies in Plant 7 starts with the outer walls. Vermeer chose precast walls not only for their protection from severe weather, but also for the insulation. Each of the precast walls surrounding the new addition of Plant 7 contain 4 inches of insulation. The roof has a rubber membrane and a hardy board under that, plus an additional 5.5 inches of insulation. The windows on the exterior of the building are also insulated with a thermal break in the frames that keep them from sweating and keeps the elements out. All this insulation, including the walls, roof, and ceiling, reduce the amount of energy needed to both heat and cool the facility by protecting the interior from the weather outside. This was a great start, but we took sustainability in Plant 7 even further. First, the robots used to move some of the carts and pallets, along with many of our forklifts, are electric. Second, the in-house patent-pending conditioned air system recycles and filters conditioned air instead of pulling in unconditioned air from the outside. And third, energy-efficient LED lights, along with ample natural light from more than 120 windows throughout the facility, help reduce our energy consumption to keep the lights on. While we may be recognized for the efficiencies found in Plant 7, our dedication to sustainability goes beyond our physical structures. Vermeer equipment installs solar fields, recycles wood waste, builds networks to share energy, and more. All hazardous waste used in our manufacturing processes in Pella is either reprocessed to be used again or is burned and used as fuel. Yes, that's 100%. And if we can reuse it, recycle it, or reduce it, we do. Wood, steel, plastic, cardboard, paper, oil, solvent, you name it. This makes us one of the largest recycling manufacturers in the state of Iowa. As we continue to grow our campus in Pella and around the world, we look forward to incorporating energy efficient and sustainable building practices into our vision. We are proud to be the first manufacturer to win the BEC award from the Department of Energy.
Hi, my name's Chris Schmiel, and I am an Athens County, Ohio County Commissioner. We're down in the southeastern part of the state, and Athens County is a very environmentally conscious community. We have the highest density of residential solar in the state. We have several solar installation companies. And we're quite proud that the Building Envelope campaign has given us an award for our EMS station number 51. Basically, this EMS station, we super insulated the roof, the walls, under the slab, the windows, and we went from the code minimum in the roof was R38, but we put in R51.23. The walls, the code minimum is R19, and we did an R37.85, and we did a double wood frame wall with wet cellulose insulation. We also had R26 underneath the slab, which was 2 layers of 3-inch EPS foam. And then the windows had a UV value of 0.22, which was above and beyond the code minimum of 0.35. one of the things, when we spent more money on the insulation, it cost about $100,000 more. But in the process of the super insulating the building, that reduced our need for our HVAC units, which reduced the cost by $105,000. So basically, building to a super insulated building envelope paid for itself automatically. We also did a lot of blower door tests, and we worked with our local contractors to make sure that every hole was sealed, and we hit the targets of minimal air leakage. And what was also great was we worked with all of our local contractors and gave them this experience of building a super high performance building. We also put solar on this building, and we believe that this will be a net zero, close to a net zero energy building. I know our first couple electric bills was like $140 or $180, which is pretty good for about a 10,000 square foot building. We're also very excited about trying to help the building envelope campaign with some other new buildings that are going to be built in the near future in Athens. We at the county are going to be building a 911 center, also talking with a Head Start school, and possibly a low-income tax credit affordable housing project. So we really believe that our built environment is one of the best ways to reduce our energy consumption. We were a part of the Georgetown University Energy Prize competition several years ago, and we're excited to have received this award from the Building Envelope Campaign, and look forward to doing more.
As a community-owned nonprofit healthcare organization that understands the connection between human health and the environment, Boulder Community Health has always been eager to employ sustainable initiatives. In addition to building the first healthcare facility in the nation to attain LEED certification, they have ongoing goals to reduce their waste stream, increase their use of renewable energy, and implement sustainable practices wherever possible. The health system is located in Colorado, in an area known for significant temperature ranges and more than 300 days of sunshine a year. From the start, the new West Medical Building at Community Medical Center in Lafayette was envisioned to incorporate a dramatic canopy that would shade the glazed atrium and could one day support a 99 kilowatt photovoltaic array. The envelope was designed to exceed code insulation values, and southern windows feature horizontal shading devices, while east and west facing windows are equipped with vertical fins. But much of the thermal energy loss and gain in a building still occurs through the windows, and the team was curious to know if there was a way to make significant improvements there. Originally, we had specified a typical insulating glass product with a low-E coating and researched the potential of a forced surface coating specifically designed to lower the U value. However, late in the construction documents phase, a glass manufacturer happened to share a new product they were working on that could potentially be a game changer: hybrid vacuum insulated glass, or HVIG for short. We quickly realized that this project was the perfect opportunity to test out this emerging technology, and Boulder Community Health was immediately on board with the idea. The team contacted the manufacturer with a pilot project proposal and soon hammered out the details of an installation. Standard vacuum insulated glass, or VIG, is comprised of two panes of glass with nothing in between them, not even air. The cavity is evacuated and kept from collapsing with a grid of tiny, almost imperceptible spacers. The vacuum itself does most of the work by reducing thermal conductivity between the materials, similar to an insulated travel mug. The food service industry has found that these thin glass panels are perfect for grocery store freezer cases. But standard building storefront and curtain wall frames are made to accommodate today's 1-inch thick insulating glass units. And it's not an easy switch to accommodate a VIG that's less than 3/8 of an inch thick. So rather than pushing for specialty receivers to accommodate the glass, the manufacturer proposed a hybrid version that married the VIG with typical insulated glass construction by adding an additional airspace and layer of glass. In addition to creating a thicker profile that can easily be accommodated by standard fenestration systems, it improves the insulated properties even further. With 3 panes of glass, it also afforded the opportunity to incorporate 2 low-E coatings where appropriate. While the original low-E insulated glass we had specified had a U value of 0.29, the installed hybrid VIGs had U values of 0.071 and 0.064. For those of you that find R values more intuitive, that's like going from an R value of 3.5 to R values of 14 and 15. This provides for a significant reduction in heat and cold transfer through the glass, resulting in more stable room temperatures and year-round energy efficiency. The addition of a second low-E coating on facades receiving higher solar radiation provided glare reduction and improved thermal comfort in sunny spaces. Much of our decision-making was based on quick shoebox energy modeling and gut instinct, but participation in the Building Envelope campaign gave us the opportunity to truly understand the impacts that these decisions were making. Software available to our energy modeler and glazing subcontractor was unable to generate the overall U values of these advanced window assemblies, but Oak Ridge National Lab stepped in and offered their expertise to calculate them. We will definitely look to this tool in the future to help understand our options and make informed choices. As a whole, the project showed an improvement of 46%. Embracing the hybrid VIG technology allowed us to upgrade the building envelope while maintaining the same window-to-wall ratio, daylighting, and overall aesthetic. It was a simple, elegant solution that we hope to pursue again in the future when the product becomes available on the market.
Hello, I'm Jeff Medwitz, Project Manager of Energy Systems for the Boulder Valley School District in Colorado. It's my pleasure to introduce you to our district and to our Education Center project, which was recognized with a Novel 40 Award from Oak Ridge National Laboratory's Building Envelope campaign. What this means is that our building's envelope showed over a 40% improvement when compared to a code-compliant building. And the building envelope is exactly what it sounds like. It's the walls, windows, roof, and foundation of a building, and it tends to be one of the most overlooked areas of available energy savings in buildings. Our district stretches over 500 square miles from the peaks of the Continental Divide to the suburbs of Denver, and we operate over 4.8 million square feet of buildings. In 2014, district voters approved a construction bond totaling $677 million for renovation projects to improve every building in the district, as well as construction of new buildings. Project efficiency goals in the building bond were guided by our sustainable energy plan, and building enclosures for new buildings were a priority for us because the envelope accounts for approximately 30% of the primary energy consumed in buildings. Since the building will be with us for decades, the envelope is a great investment because it helps to improve indoor environmental quality by keeping the outside outside. And a tight building will result in a lower utility spend, which is our second greatest annual expenditure after salaries. The Ed Center consisted of a series of buildings, parts of which were originally constructed in 1963. Because the facility had both functional and structural deficiencies, the older east side of the existing building was demolished and replaced with a two-story addition. The project team engaged in a highly collaborative design process to reach the district's energy, functional, and budgetary goals. And then we contracted an independent third-party energy consultant to join the team to provide a number of services, including energy modeling, design reviews, mechanical and lighting commissioning, as well as building envelope commissioning. The consultant also supported the design team by providing detailed energy and performance analysis, and daylight analysis was performed early to help make educated decisions for the enclosure. The exterior wall assemblies were constructed using a non-structural, rigid insulated board sheathing, and careful attention was paid to sealing the system to itself and sealing all transitions to adjacent materials. The combination of exterior materials produced a deep wall cavity that created built-in shading due to the deep reveals at each opening. Window glazing is tuned for the specific facade orientations. Windows feature both vision and daylight sections of glass and exterior sunshades. And then all the attention to detail allowed the Ed Center's pressurization or air leakage test to exceed our goal by almost 50%, which exceeds code by over 30%. Budgetary limitations were probably the greatest challenge for the project team. This required a thorough study of the envelope's materials and how to strategically address daylighting, all while balancing the impact on mechanical system. Another persistent challenge was the failure of water intrusion tests for some storefront assemblies. Water is the enemy of building enclosures, but the entire team discovered that a simple fix of new sealant at the storefront assemblies was the solution to the problem. Boulder Valley's energy goals were supported by a durable, well-insulated, and tight building envelope for the education center. And we're grateful for the engaged and collaborative team of architects and engineers, energy consultants, commissioning professionals, and contractors who helped the project finish successfully. We're honored that all the work on the project was recognized with a Novel 40 award from the Building Envelope campaign. This award reaffirms our commitment to provide our staff and students with healthy, energy-efficient buildings, which start with the building envelope.
Hi, my name is Ivan and I'm a building performance analyst for McKinstry. I am here to highlight the Catalyst project as part of the Better Envelope campaign. The Catalyst project is a mix of higher education and office building located in Spokane, Washington as part of the South Landing campus. My role as an analyst in the project has been involved in the performance of the building, helping inform decisions through design and construction as it relates to the energy use of the building. The Catalyst project has high ambitions in terms of sustainability and energy reductions, and these two things are well represented in the building envelope. The building envelope is not a typical business-as-usual commercial construction. It uses mass timber in the form of cross-laminated timber, or CLT. Through sustainable forestry, mass timber construction significantly reduces the carbon impact in building construction. Compared to traditional concrete and steel, CLT has a much lower carbon impact and has the ability to store carbon from the atmosphere in the material itself. The building is also blanketed with exterior mineral wool insulation, both at the vertical and horizontal assemblies. The windows are all triple pane with thermally broken framing systems. Great care has been taken in the design to reduce the number of thermal weak points. The construction process was diligent in minimizing the air leakage, testing at rates lower than the Passive House standard. Overall, the building is highly thermally insulated and airtight, minimizing the building's exposure to exterior elements. All of these envelope measures compound and significantly reduce the building's need for heating and cooling. This is all tied in and integrated with a highly efficient heating and cooling plant at the campus, resulting in one of the world's largest zero-energy, zero-carbon buildings. The importance of a high-performance envelope is evident in the Catalyst project, and McKinstry would like to thank Oak Ridge National Laboratory and the Better Envelope campaign for recognizing the building and its envelope design.
Well, of the whole integrated project, the elements that I like to say the least sexy but most important are the building envelope. With the foundation of a great envelope, all the other features that we add on to it are just really additive to the reduction of energy. So it's just a really important element. Hi, I'm Steve Hennigan. I'm the CEO of Credit Union, Federal Credit Union in San Antonio, Texas. The most important things in a good building envelope are you're trying to control for three fundamental areas. You're trying to control for thermal, you're trying to control for bulk water, and you're trying to control for air infiltration. Most buildings really only go after two of those items. Air infiltration somewhat being left behind. In this case, if you can really get the air infiltration numbers really tight, it makes the building extremely efficient. Started with a really great set of glazings, and then we wanted to make sure that the inner and outer walls broke all the thermal bridging. Then we want to actually put a membrane layer on the top to allow for really just solid air infiltration. And then ultimately we wrap the building in a wool layer. When you put the whole assembly together, it's really designed to just be an outperforming wall. They actually even did mock-up design before they actually started building the actual building walls.
That had a lot to do with wanting to test and understand the building components before we actually had to build them. It's not only a technologically advanced building, but it's a one-of-a-kind building as far as all of the architectural details. You know, the brick details are endless, how the walls all tied together, and how we were frankly going to make the air barrier work with all these systems being tied together. So we put a huge effort into building that mock-up right down the street, and we learned a lot from that mock-up because we realized a lot of things that wouldn't have worked. But that was a huge step in skipping past some of that learning curve because we were able to deal with it on a small mock-up, you know, half the size of this room, instead of learning it on the building in the middle of construction.
The other thing that we did is that we did 100% testing of every brick type. Basically, there's a gel coating on that wall system to make sure that no air is getting through it, and then you perforate it, and you want to make sure that the perforation is completely sealed. As they were building the wall assembly, we had a tester testing every one of the brick ties, and so when they started on the south facade, they had a high failure rate, which means they come back and they remediate it because they hadn't covered it up yet, so they can remediate it before they go on to the next layer. And as you begin then to remediate that, the team gets the feedback from how they were making errors, they adjust the process. So by the time we got around to the third wall, the production technique had been perfected by the workers. And so, you know, this process just led to a better and better wall assembly all around the building.
One of the big test days for the general contractor was the blower door test day, and you can imagine putting a blower door test on an 8-story building. They had to seal it all up. We'd set a standard for the building of 0.1 CFM per square foot at 75 Pascal, and they actually achieved it on the very first test. They actually got it down to about 0.088. So it was just an amazing accomplishment for that team that had, you know, really worked hard, and they were rewarded well for the results. So as we do more and more of these projects, it's like anything else, we're going to get better and better at it. The learning curve is going to increase. The trades, the crafts, and the workers that are doing the specific work on these buildings, and I know particularly the crews that were on the exterior facades of this building, they are very proud and to be part of this.
A lot of times on a job, things are budget driven or time driven, but this job felt a little different. The battle cry from day one was it has to be right? Like it has to be as close to perfect as possible.
Well, I just want to really first thank the Department of Energy for the campaign, because I think it's a really important element for building design going forward. For us to be part of this first year campaign, we couldn't be more pleased. And, you know, just really glad that our building made the test. And so hopefully this will stimulate more buildings to be done this way, and that allow the Department of Energy to, you know, just really progress and further the programs that they're trying to advance with regard to energy efficiency.
Originally built in 1896, Barracks 246 in Fort Myer, Virginia has been home to cadets in training for the 3rd U.S. Infantry Regiment. Also known as the Old Guard, the 3rd Infantry is the Army's official ceremonial unit and escort to the President. The building itself is in the heart of the Fort Myer Historic District and as such is a protected historic resource. The historic windows, which are shown shaded, were supplemented with new, double-glazed interior storms. This strategy allows the existing windows to retain their historic appearance in compliance with the historic district requirements. Careful coordination of the insulation layer with a new interior structure allowed the team to align the insulation with the airspace between the historic windows and the new interior storms, creating a continuous insulated layer throughout the building. Prior to renovation, outdoor temperatures easily passed through the single-weight glass historic windows. This analysis shows a dramatic improvement that increases comfort in the occupied space without additional mechanical inputs. Critical to the restoration of historic buildings is the consideration for moisture migration and freeze-thaw cycles. When insulating old brick masonry walls, the ability for the wall to dry is extremely important. Too much insulation could result in water freezing inside the wall, which can cause the brick to crack or spall. Our team analyzed multiple systems to determine the ideal thickness of insulation and the best application of a vapor permeable membrane. The team settled on a continuous layer of 3-inch mineral wool with an airspace behind the insulation layer to allow water vapor to dry without impacting interior finishes. To protect our patrimony, every aspect of energy and envelope improvements that could negatively affect these historic structures must be considered. The existing mechanical systems were beyond their useful life and inadequate to serve the building. A new dedicated outside air system and increased ventilation allowed for control of not just the temperature, but also the humidity and air quality. The existing attic spaces were in poor condition, with low ceilings and minimal, discontinuous insulation layers. The wood frame roof had its own set of challenges, and consideration must be given to ventilation of the framing to minimize the chances of trapped moisture, which leads to deterioration of the wood. A second critical factor in improving the envelope was the requirement to preserve the historic dark gray slate roof. Mitigating heat gain in the attic had to start with a reduction of the overall load in order to allow for the most energy efficient systems to adequately serve the space and preserve occupant comfort. A ventilation space between the roof shingles and the insulation layer drastically reduces the effective heat gain from the shingles while simultaneously allowing for a continuous air path to vent the wood framing. Locating the increased insulation layer at the rafters combined with the roof venting system greatly improved comfort in locker and shower spaces. Training and meeting rooms were open to the rafters, creating a space where warmer air can stratify at the top while the cooler air remains below. The combination of both passive and active strategies allowed for greater reductions in the mechanical system sizing without compromising occupant comfort. The glazing assembly now performs 67% better than it had. The walls and the roof are almost 3 times as efficient as they were, and HVAC improvements have eliminated the window unit air conditioning seen throughout the attic spaces prior to the renovation. These strategies resulted in an overall improvement of the building envelope performance value of 47%, while preserving an important historic resource for future generations.
Thank you for watching the American Geophysical Union's video about our net zero energy renovation of a commercial office building, the first ever completed in Washington, D.C. I'm Janice LaChance, AGU's Executive Vice President of Strategic Leadership and Global Outreach, and I have led the project for the last 3 years. AGU's building is 62,000 square feet, located in the DuPont Circle neighborhood of Washington, D.C. Led by our volunteer board of directors, AGU realized that updating our headquarters could be a very visible commitment to our mission of advancing Earth and space science for the benefit of humanity and the environment. Also realizing that it could be a model for others interested in sustainable building practices, they chose to become the first net zero energy renovation in the nation's capital. To achieve net zero energy, AGU's design focused on 4 key principles: reduction, reclamation, absorption, and generation. To achieve these goals on a tight urban footprint, we considered and tested 50 strategies and ultimately selected 23 that could be combined to meet our net zero energy goal. For today's discussion, let's focus on the building's envelope: the windows, the walls, and the roof. The windows are high-performing triple pane glass that were optimal for us from a cost and life cycle perspective. To shade the glass, we used dynamic or electrochromatic glazing, where the glass shades itself to reduce the amount of solar heat gain that passes through the windows. No shades, blinds, or curtains are needed. We've also linked the windows directly to the building's energy management system. The windows react to the heat, and that helps control the temperature. The windows are also tied to the lighting. As the windows tint darker, the lights get a little bit brighter. There are also overrides available throughout the building. Every single pane of glass in the entire building can be operated independently from any other pane of glass. Next, the walls. We added 8 inches of closed cell spray to the exterior walls, resulting in an R value of 15.7, and that more than doubled the insulation during the retrofit. The envelope has a 30% window to wall ratio. Lastly, the roof. Unlike other buildings that may not be in highly dense urban areas, our ability to use solar power is very limited. At the same time, we also wanted to make sure AGU staff and our tenants were able to use the roof for breaks or meetings and to experience the great view. We installed 13,200 square feet of photovoltaic panels elevated above the 12,130 square foot roof. The 250 kilowatt PV arrays can generate up to 100% of the building's total energy when combined with the other net zero design strategies. In addition, the solar panels provide shading for our staff and tenants when they are enjoying the roof. Today, we focused on the building's envelope, the windows, walls, and roof. And these are only 3 examples of how the AGU building renovation achieved our goal of net zero energy. Do visit our website to learn more, and we appreciate your attention. Thank you.
This is Gregory Walker of Hauser Walker Architecture, Principal Architect for the ASHRAE Net Zero Energy Headquarters renovation. As our team began the design process, we knew the building envelope was going to be called upon to resolve a number of critical components that would drive a successful outcome for the overall project. The components that we knew would drive a successful building envelope design included addressing the insulation at the walls and roof, limiting the air infiltration to a very low rate, determining the proper window-to-wall ratios for each elevation and orientation, creating high-performance window assemblies, and determining how to most effectively utilize external shading assemblies. As we began, we were also mindful of the existing conditions that we needed to address in the design, including a series of precast panels that had defined the prior envelope, as well as a highly insulated existing roof. Our team also determined early on that if we could right-size a number of the building envelope concerns, including the window-wall ratios and daylighting, that we could reduce the overall EUI points by about 6 to 6.5 and really enable us to reach the baseline target that ASHRAE had set of 21.4. To help aid us in that effort, our friends at Integral Group and Elementa helped devise an envelope sensitivity analysis that helped tell us what each of these key components needed to target and where the points of diminishing returns would occur. This was incredibly useful to have early in the process, as it allowed the entire team to be aligned around what were the end metrics that we needed to hit and know that if we hit them, we could be confident in the outcome that would follow. This analysis was also incredibly important for our HVAC engineers so that they could design the project in tandem with the envelope, and we didn't have to rely on one or the other to be finished or fully resolved before moving forward. As we began designing the exterior envelope, it quickly became apparent that the only way we would be able to address the insulative and air infiltration performance needs for the envelope was to run a continuous system over the outside of the existing precast panels. This is option B as shown on the right. In doing so, we had a couple of options to look at, and for schedule and budget reasons, we went with an EIFS-based system that had a fully drained stucco finish on the exterior. As we looked at the window-wall ratios, we had a target of 40% to begin, but as we did the specific design, we found that a 33.5% window-wall ratio on the east and west and a 41.9% on the north and south would not only address the energy concerns, but also allow us to address ASHRAE's spatial daylight autonomy concerns. Another often overlooked aspect of envelope design was to consider what could we do with the roof. And in this case, we found that 18 well-placed skylights on the roof would also help us achieve the daylighting autonomy goals. Finally, we also considered how to best leverage a lightly tempered atrium, which just meant that we ran the set points higher and lower in the summer and winter, and it allowed us to bring in generous amounts of daylight to a space that was going to be used primarily as vertical circulation. In summary, we were able to meet all the original design targets that the team had set early on in the project, and we did so utilizing conventional building practices, conventional materials, and staying within a conventional renovation budget. In this regard, we hope that the ASHRAE headquarters renovation provides a kind of template for future owners and designers to consider as they pursue their own high-performance renovations.
Hello, my name is Troy Kerr, and I'm a project manager with FGM Architects. And I'll be presenting our project at Prairie Trails School in River Trails School District 26. Our project was a comprehensive retrofit of an existing facility into a net zero energy, high performance building. River Trails School District 26 is small but diverse. It is a district in the northwest suburbs of Chicago. It services around 1,600 students at 4 schools. The building we are looking at today, Prairie Trails, will serve as the kindergarten and pre-K facility beginning in August of 2021. Prairie Trails School is located in Mount Prospect, Illinois, northwest of the city of Chicago, and about 5 miles north of O'Hare Airport. There are 2 buildings situated on the Prairie Trails campus: the school, which is here designated by the number 2, and the district maintenance facility designated by number 1, which helped to house our PV panels but was otherwise uninvolved in the project. Prairie Trails was originally built in 1966 and has remained largely unchanged in the years since. Most of the building's original systems remained intact at the time of our project. Due to increasing enrollment, the district needed to bring Prairie Trails online as a full-time school. Doing so required that many of the outdated systems be updated, And given the district's commitment to sustainability, the decision was made to pursue making this facility net zero. In addition to retrofitting the building systems, the project utilizes roof-mounted photovoltaic panels to generate the electricity needed to offset building energy usage. This is a plan of the school. It's important to note that no new square footage was added as part of this project. Everything was achieved within the footprint of the existing building. In this diagram, the classrooms are highlighted in blue and are located on the east and west sides of the plan. In this case, north is to the right. The school office functions are shown in yellow. The district administrative offices are shown in orange. The multi-purpose room located here in the center of the building is highlighted in green, and the building support spaces are shown in gray. The project, and especially the net zero energy retrofit, were made possible in large part due to a grant received from the Illinois Clean Energy Community Foundation. One of the grant requirements was that we pursue third-party verification of our net zero energy performance. In this case, the team opted to pursue Passive House FIAS Plus Source Zero certification. FIAS certification required that we update all major systems in the building to be extremely efficient. This included the roof, exterior walls, windows and doors, mechanical, electrical, and plumbing systems. For the purposes of this presentation, we will be focusing on the improvements made to the building envelope. The roof started as a tar and gravel built-up roof over minimally tapered insulation, slope to drain. The roofing was replaced with a new EPDM rubber membrane, and the insulation was increased to 10-inch minimum thickness, or R65. The original exterior walls were made of load-bearing CMU with an exterior face brick width. We removed the face brick and kept the structural CMU in place. New structural metal studs were added in the former brick location, followed by new gypsum sheathing, new fluid-applied air barrier, 4 inches of new rigid insulation, new thermally broken rails, and new fiber cement siding, both of which can be seen in this photo. In addition, we added 6 inches of rigid perimeter insulation around the foundation. Here are two details of our new walls. On the left is the detail where the below-grade insulation meets the above-grade wall. On the right is the detail where the wall meets the roof insulation. Both were critical junctures to ensure continuity of the thermal and air barrier assemblies. All of the windows and exterior doors were also replaced on the project. Existing windows were aluminum, not thermally broken, with single-pane glass. Doors were a mix of aluminum and hollow metal. The new glazing consists of aluminum curtain wall with triple pane glazing. New doors are thermally broken aluminum or insulated fiberglass at locations of opaque doors. Our envelope performance was an area of focus for the FIAS review. The next few slides showed the impact of envelope improvements on overall building performance. Here we can see the energy balance of heating and cooling for both summer and winter. In summer, a large majority of the cooling comes from the slab on grade, while about 25% of the heat gain comes from the exterior walls and windows. In winter, nearly 70% of our heat loss is through the exterior envelope, even in our much improved conditions. This slide shows the heat gain and loss through the windows. Here you can see that the large windows in the classrooms on the east and west side of the building provide the largest sources of heat gain and loss. This slide shows the heat loss through various building components. Here you can see that the slab on grade is the overwhelming contributor to heat loss. In our case, the slab on grade was the only envelope component that remained as is. All others were replaced. During the construction process, we performed a number of tests to confirm that construction conformed with the design intent of the high-performance assemblies. This included thermal scans of the envelope and blower door testing. Interestingly, the envelope passed the blower door test on the first try with flying colors. However, leakage through the exhaust dampers on the roof-mounted mechanical units caused the test to fail initially. This was corrected later, but it was interesting to note that the envelope components were actually not contributors towards the failure of the test at all, but rather mechanical units, which is not something that's typically considered. These last few slides will go through some of our envelope components during construction. In this slide, on the left, you can see the new structural metal studs, the cold form framing, going up over the existing CMU. Also in this slide, you can see the new gypsum sheathing going up. On the right is the excavation for the new foundation insulation. Again, that was 6 inches thick around the perimeter of the building. On this slide on the left, you can see the gypsum sheathing in place with the new fluid applied air barrier going over it. Spray foam insulation, you can see on the far left, was utilized at the parapet condition to join the wall assembly and the roof assembly together with no thermal transfer. On the right is the new below grade insulation going in. Stainless steel flashing was applied where the insulation met grade to protect the insulation from any lawn maintenance activities. On the left is the new door and window system going in. Again, it's thermally broken curtain wall and thermally broken doors. You can also see the tie-in of the air barrier to the window assembly. This was a critical juncture to ensure that we met the air leakage requirements. On the right is the new insulation with the new rain screen attachment or thermally broken rail system. In closing, the envelope improvements at Prairie Trails were an integral part of the deep energy retrofit that contributed significantly to the transformation of this existing building. Thank you.
Awesome, that was great. I loved hearing about all of the buildings that were recognized this year. To make sure that we do get all 14, I wanted to tell you a little bit about this last project that wasn't able to submit one of those videos, but this was a community housing project, Virginus Community Housing, that was submitted by Evernorth and is located in Vermont. And they received a Novel 40 award. So this is a newly constructed mixed income multifamily rental property with 24 apartments and indoor and outdoor amenities. The development was designed with a passive house air sealing target, native plantings, low flow fixtures, fresh air ventilation system, low VOC finishes, and passive daylighting strategies were applied to this project. To improve their energy use, they used photovoltaic systems, LED lighting, and triple glazed windows. Additionally, this property has a heat recovery ventilation system and a high performance mechanical system. This is a walkable and bikeable site that has a community gathering space, infill development, and access to public transportation. The property was constructed with durable design and materials that meet Efficiency Vermont's high performance standard for multifamily housing. And resulting from the collaboration of a diverse team of passionate experts, this development incorporates the needs of the residents, the community, and the environment. So that is our 14th building. And now you have heard from everyone who we awarded this year. So if we were in person, I would ask for you to give a big round of applause to these, and hopefully we can be celebrating in person next year. So congratulations again to all of our awardees from this year. Next slide. So we do have one final poll for you guys, and this is just because Slido is not linked into the GoToWebinar functionality. I want to know whether you need any more information from me about the campaign. So, if you hop back over to Slido, you can either indicate whether you already signed up and you already communicate with us, or whether you would like for me to reach out to you, and then you'll have the option to drop your email address in if your answer is yes. Again, this is because the Slido functionality is different than the GoToWebinar, and so I do need you to indicate yes and enter your email address, although your email address will not pop up on this screen here. So I will give you guys a few minutes to come back to your screens, find that Slido tab, respond to this poll, and enter that email address if you would like for me to reach out after this webinar. If you don't get to this or don't enter your email address right now, my contact information will be up at the end of this. You can also reach out to us on the Envelope Campaign website. So this definitely is not your only chance to get in touch with us. We can give this another couple seconds, but it looks like these numbers have leveled out a bit. And hooray for all of you folks that are already signed up and already get our monthly newsletters and all that good stuff. So yeah, I think we can go ahead and close this out. And move on to the next slide. Perfect. So that is a wrap on the 2021 Building Envelope Campaign recognition. Again, thank you so much to all of our participants for submitting buildings this year, for submitting those videos for us. And again, hopefully we can all celebrate in person next year. As I mentioned earlier, this webinar is a part of the 2021 summer webinar series. We still have 2 great presentations happening in August, so please visit the Better Building Solutions Center to register for those. Next slide. We do specifically hope that you join us for the one on August 3rd. That's our very next webinar, and it is titled Waste Reduction, Lessons Learned and What Comes Next. For 2 years, DOE has worked with over 40 Better Buildings and Better Plants partners to identify and share waste reduction strategies for multiple sectors. So if you will please join us, you'll get to hear all about lessons learned and what comes next. Next slide. To watch recordings from the Better Buildings Virtual Summit or previous Better Buildings webinar series, or technical presentations from the National Labs, please visit the On-Demand Webinars library where all previously recorded presentations are archived and where this one will eventually be. With that, I would like to thank again all of our participants for taking the time to submit those videos. It made for an awesome webinar to hear all about all the different projects from this year. Do feel free to contact me directly with additional questions. You can also email the campaign directly, although I monitor that account, so you'll get to talk to me either way. If you have any more technical questions and I don't know the answer, I will certainly set you up with someone who does. I also encourage you to follow Better Buildings on Twitter for all of the latest news. You will receive an email notice again when this offline Q&A is ready and when this archived session is available on the Better Buildings Solutions Center. So thank you very much, everyone. Happy Tuesday, and congratulations again.